So going in, what we saw in last lecture was we saw what was vector quantities and we saw what was scalar quantities, and this lecture is about the vector representation. Then we will see the vector addition, and then I will tell about the vector subtraction. And so a vector is something which is having both a magnitude and direction. So by just demonstrating that by taking a quick example of a velocity vector. So suppose this is a coordinate system x, y, z this is a Cartesian coordinate system used to represent a vector. So I am having the origin here, and I am having a point P in space, which is represented by x, y, z. So OP is a vector which is a position vector. So OP is something known as my position vector, and the direct unit vector in the direction OP is given by as OP unit vector. So this is a unit vector. So if I am having a velocity, this is a plane which is moving from O to P. So if I want to say that the velocity vector of that plane VOP can be given as 100 kilometer, which is a magnitude. So this is a magnitude, which is a plane is moving at 100 kilometer and it's moving in the direction given by the unit vector OP. So it's possible to represent a vector with both magnitude and direction. So such quantities, just by taking an example of a velocity vector, I have just demonstrated how it's possible to have a vector which is having both magnitude and direction. Unlike if the same case which could have been a scalar, it would be having only magnitude. It would not be having any direction. So in that case, this could be simply said as the speed of the plane is 100 kilometer. So this is a scalar quantity, which is speed. So that's how you have defined the vector quantity and the scalar quantity. And the next is about how to represent a vector or how to draw a vector. So this is one of the ways to draw the vector, which I will be simply saying as a vector OP can be drawn as starting from O and going to P. And if I'm drawing it in this way, and then I'll say that the direction of the vector is from O to P. Direction is from O to P. When I'm saying the direction is from O to P, the direction will be given by a unit vector OP dash, which is equal to the unit vector. And again, this is my tail, and the direction in which the vector is moving is known by my head. So for this OP vector, which is moving from O to P, can be represented by an arrow, simply an arrow, and it can be represented by O as a tail and P as a head. So that's how you are representing a vector. So to be more clear, next step is that after the representation of vector, if there are two vectors, you can also do addition of the vector. So I'm simply saying that I have a vector A and I have a vector B. So this is my Cartesian coordinate system. If I simply take to represent the vector, and this is Z, this is X, this is Y, and this is my A vector, and if this is my B vector, both are starting from O, but I'm not considering it O, I'm simply saying this is my A and B vector. Now I want to do addition of A vector plus B vector. The simple way to add the vector is that I am taking this whole vector and I am putting the tail of this vector on the head of this vector. So by simply doing that, I am just drawing the vector. If I am drawing this according to scale, this is not according to scale, but if I am simply drawing this according to scale, then I can simply take this according to scale and accordingly put it as it is here. Same way here. So this is my B vector. So I've drawn it here, and when I will connect it from the origin, what I will have is a plus B vector. So in this way I have added the A vector and the B vector. And when I have a vector, when I'm saying that this is my A vector, this is in this direction, and I am having a minus A vector, so I will simply reverse the sign. So the same vector, if it is written going in the opposite direction, it will become a minus A vector. So when I say that I am doing the subtraction of a vector, to do that, if I'm doing A minus B, A vector minus B vector, if simple way to do that would be to add the vector with the minus of the B vector. So I will just demonstrate that. If you are having your A vector, so to simply demonstrate that, you can have the opposite of that same vector here. So the opposite of the B vector would be something like this. So this would be minus B vector. When I'm adding this vector, I will add it here. So the tail will come here, and this is my minus B vector. So I have added this, and this is something like my A minus B vector. So that's how you are doing the addition and subtraction of the vector. So again, this is not as per scale, so this is just for representation. So this is not per the scale, this is just for the representation, and this is how you can do the addition and the subtraction of the vector. And again, it is possible to algebraically add magnitudes or algebraically multiply magnitudes to the vector. So if I'm having a vector A, and if I'm adding it by magnitude of 10, then this will become 10A. Or if I'm having a plus B, and if I'm both doing it, multiplying it by magnitude of 10, then it will become 10A plus 10B. A simple example could be a plane is moving from the point O and it is moving to a point P, and the OP magnitude is 10. The OP vector magnitude is 100, which is a velocity, and if I'm adding it by multiplying it by a scalar which is 100, 10, then the whole velocity would now become 1000, but the direction will not change, it will remain the same. So this vector now, it can be drawn like this, so, or it can be drawn, it can be extended further, so it will become now OP vector with a magnitude of 1000, but the direction or the unit vector in the direction will remain same. So that's how a scalar multiplication on the vector will act. You can multiply scalar with vector. So this was all about this lecture, in which what I said was about the representation of vector, the algebraic addition of two vectors, the subtraction of two vectors. Then again, this was multiplying a scalar into a vector. So this will only increase the magnitude, but there will be only magnitude increase. There will be no direction change. So this was all about knowing more about vectors, and in the next lecture what I will see is tell about is how to represent a vector using the Cartesian coordinate system. So the next lecture is about how to represent the vector using the Cartesian coordinate system, and then what is a unit vector, and after that I will say about the dot product and cross product of vector.